Okay, I'm back. So this would be lesson 6 for my Python physics series. So let me just tell you where we've been and where we're going, just so that we're all on the same page here. This is a series of lessons to learn Python in the realm of physics. So my original idea is for faculty that want to use Python in their class. But it could be students too, and I think it'd be just as fine for physics students. I'm going to assume mostly you will already understand the physics ideas, so I'm not going to focus on the physics. And so what I've done so far is how to use Python as a calculator, how to make basic numerical calculations, how to make visual 3D visualizations. We did projectile motion, and in the last one, I built this program right here, which I'm going to modify and make it even better. This is a calculation of the range of an object as a function of launch angle. And so the important thing here is that we learn about functions, how to make a function. So I make a function here. I will make a quick comment. This is not perfect Python. This is physics Python. Okay, and I think this is an important point to make. I think there's a big intimidation factor when people start programming. They think, well, I could do it as a function, or I could do it in this copy-paste way and just recopy things multiple times. But I don't think that that's the right way, and I don't understand functions, so I'm just not going to do it. No. Do it the sloppy way. If that's what you understand, I think it's way more important to understand and take ownership of that program than to do it some way that you don't understand. And that's my whole philosophy here, is to let's build programs that you create and that you understand. It doesn't matter if it's not good enough for anyone else to see. Just program. And that was a song. Okay. Okay, well, let's get started. So this is the program that I made in the previous lesson. This is for projectile motion, and I wanted to see what angle gives the longest range, and it actually works even if you start the ball not at y=0, but here I have the ball launched from a cliff. So this is the range, how far it goes along the horizontal axis, and this is a function of the angle. And you can see here, in this case, I launched it, let's see, what did I do? Trying to remember here, R0. So I launched at 2 meters above the ground. That's what this 2 right here is. And with that, the maximum range, you can kind of just get it from here as 35.9 degrees. Now, I want to add air resistance. I want to do some cooler stuff. So, I don't want to get the max range from the graph. I want to actually print out the max range. So let's do this. Let's copy this. And let's say, I'm going to give it a name. Oops. Ball toss, air max range, air resistance, and copy of. I don't need that. Okay, let's make this a little bit smaller. I like the double window thing. Okay, and that might be too small, but I don't really have anything else. I'll say, let's see if I make this a little bit bigger. No. Okay. So the first thing I want to do is this function, p range, all it does is it launches the ball and it tells you where it ended up. Okay, so it doesn't give you the max. Down here I have a loop where I launch it at different angles and I just plot the range. So what I want to do is to kind of record the maximum range. So this is what we're going to do. I'm going to say m range equals 0. That's my maximum range. And then I'm going to calculate the range, and if that range is greater than that, then that's going to be the maximum range. So it's pretty easy to do. So here I can say, I never really had a thing on if statements, did I? That's my fault. Okay, well, here's an if statement. So I'm going to say if t range, that's the range that I just shot it at, is greater than m range, then colon. You notice the colon is a common theme for functions and while loops and all that stuff, and tab indents is common too. Then I can just tab indent. Anything tab indented is part of that if statement. So if the range is greater than the previous maximum range, then m range equals t range. So if it's not greater than that, then it doesn't change it. So what it does, every time it gets greater than that, it sets it. And so this makes the assumption that it's not going to get greater than and then get greater than. No, that's fine. Yeah. Okay, so let's just print that out. It'll go through the whole loop, and I'm going to outdent, and I'll say print max angle, max range at, oh, now I need the angle. Let's do that too. M angle equals 0. And then, so if that's the maximum range, then I'm also going to set M angle equal to theta. And that's in radians. Max range at theta equals, I want this in radians, so I'm going to say M angle times 180 divided by pi, that converts it back into degrees. Let's run this. 37 degrees. What do you think about that? Okay, now you'll notice here that I'm at 37 right here. Let me just change this to G dots so you can see something. So G dots does not connect the lines, it just puts a dot there. If I run that again, you can see that they're finite steps, right? So I'm kind of surprised it's right at 37 degrees, but I think that's okay. I thought I'd see a dot, but okay. There you go. I have it. I have the maximum range. Okay, next thing I'm going to do is to change this back. And I am going to add air resistance. So I'm going to use the same air resistance that I had in the previous case, which I don't remember what it was. Let's see if I go over here. And my trinket, I'm just going to copy it. These are all my programs. Max range. Ball toss with air drag. Okay, so really the key thing is I used a ball mass of 50 grams. Oh no, that was the other one. Ball 2 had a mass of 20 grams and a radius of 0.05 meters. So let's put that in here. So I'm just gonna down here. I'm not gonna pass that to my function. It's just gonna assume. Oh, here it is. Let's put that in here. 0. It says 0, 2. R, capital R, let's call it radius. No, let's call it capital R. Capital R is, what did I say it was, 0.05. Is that right? Radius. 0.05, okay. I need the density of air, rho is 1.2. I need the drag coefficient, C, is 0.47, and I need the cross-sectional area. Area equals pi times r squared. So down here, I'm going to, and I did this before in my calculation on modeling the motion of a ball with air resistance. So down here, I'm going to say the net force is m times g, which is a vector, and then I'm going to say minus 0.5 times rho times a times c times the magnitude of the momentum or the magnitude of the velocity. So let's just say mag p divided by m. Did I put the m in there twice? Oh, no, I didn't. Squared times the unit vector v, which is the same as unit vector p. So now I have this extra component in my air drag force, and that's it. That's all I have to do. So let's just run it. Here I have it at 37 degrees. I'm launching from 2 meters, but that's fine. And let's do it again. And you see it starts looking really weird, which is awesome. Okay, it curves up like that. It's not what you'd expect. But here the maximum range is not 37 degrees, it's 46 degrees. I think that's awesome. Okay, let's put this back down at the ground and run it. And the maximum angle is 50 degrees. I think that's wrong, right? The maximum angle should be less than, I think it should be less than 1/2. I'm thinking of this rho AC. It should be less than 50 degrees because you want to be in the air less time. Vector v start. Let's try a slower velocity. 4. Now it's 45, 47. That's weird. Let's try it at super high velocity. Well, let's try this. Oh, minus minus. Is that why? Yeah. Wow. Okay, so let me put this back down here. The V start as 7. And the max range 43. Okay, it's working the way I expect. So, and the reason the angle is lower than 45 degrees, because if you shoot it up higher, then it's going to be, even at 45 degrees, it's going to be in the air longer, and it's going to be slowing down longer. So you lose that horizontal velocity by spending more time in the air. Let's just try change this to 11. Let's see what happens. Okay. Now, but see, here you can see what I want to explore. How does the maximum range relate to the initial velocity? So what if I want to do that? I want to change the velocity and find the max range. Then in that case, I kind of need a function in a function. But I don't have to write it as a function. This one right here finds the maximum range. I could indeed make that as a function. But let's just do it without a function, just because I think it makes more sense to people. So what I'm going to do is make a loop inside of a loop. So I'm going to start with velocity of 1 meter per second, and I'm going to have dv is 0.5 meters per second. So I'm going to launch it at this velocity, and I'm going to find the max range. And then I'm going to plot that angle and the velocity. And then I'm going to, so I want to have the angle, max range angle versus launch velocity. And then I'm going to increase the velocity and do it all over again. Okay, so up here, let's change our graph. So my x title is actually going to be launch velocity. I'll just call it V0. V0 in meters per second. And my y is going to be max angle. It's not the maximum angle. Let's call it max angle. It's not actually max theta in degrees. It's actually not. It's the angle that gives the highest range. It's not the maximum angle. That'd be 90. So, but you know what I mean. We understand, right? Okay. So up here, I'm going to have to reset all my stuff. So I'm going to make another loop. I'm going to say while v start is less than 15. Now I'm going to tab and indent all this stuff. Not that. Let's just delete that. Yeah. Okay, so this is going to set the initial parameters. So my v start is already up there. I'm going to reset my theta. I'm going to put this actually down here. Because every time I start this loop, I need to start that over, right? I need to have my theta start at 1 degree. And then I'm going to go through, I need to reset my max range, reset my max angle, and then this goes through and finds the maximum range. Now, after I find the maximum range, that's what that whole thing did, I'm going to plot it. So I'm going to say f1.plot. I'm going to plot the maximum, so I'm going to plot the velocity. Oh, so I need another v max. No, I need it is velocity. So it's just going to be v start versus the angle, theta times 180 over pi. Now I'm going to increase the velocity. So v start equals v start plus 1 plus dv. And then I'm not going to print this. And let's see if that indeed works. Saving it, because this could be in an infinite loop, and that would make everybody sad. Okay, trying it out. The max angle for velocity. Okay, so something went wrong. Oh, that's right. This should be not theta. This should be m angle. I like that. That's exactly what I was expecting. So you may think this is whack. It's whack. Okay, but you got to realize I'm doing a loop inside of a loop, so there's a lot of calculations going on here and takes some amount of time. On top of that, why does it go up and down? Well, it's not really going up and down. You got to think, when I break the initial launch angles at discrete values, and my launch range is at discrete times, it's possible that I could actually increase the velocity and have it could round up or it could round down. So this is the problem that I get. So how can we fix this? Well, one way is we can increase the step of degrees. So here I have d theta is 1. What if I change this to d theta is 0.5? Now I'm going to have a lot more runs, right? It's going to take longer to run, but you'll give a better graph, I think. Yeah, so there you go. And then I could also increase the time step in my function up here. That's actually pretty small. Let's keep it like that. I could decrease the dv here. Let's put this at 0.2. I'm really pushing into too many data points here, too many loops here. You can see it's taking longer and longer to run, but I'm willing to sacrifice for science. Okay, that looks pretty good. So you can see, let's just see what this whole thing means. If I launch with a faster, higher velocity, the angle for the max range decreases. And that makes sense, because if you go really, really fast and you shoot it up high, it's gonna literally stop in the air and just come straight down. It's not gonna give you anything useful there. But this is a way that we can make these kind of loop function things. I would like to point out here, yes, there are better ways to do this, but this is the way that you can understand. 2, I don't want to display the 3D animation because it just makes things more cluttered. 3, let me give you 2 pieces of homework. I don't normally assign homework. I'm assigning homework. Number 1, I'm going to put this in here at the top as a comment. Homework. Homework. Okay, let me put this. This is bothering me. So note these 3 quote marks, starts and ends a comment. This only works in GlowScript because it's actually a Java thing, a JavaScript thing. So just so you know, it doesn't always work. 1. What if, this is a good one. What is the relationship between max launch angle and ball radius? So assume B rho, the density of the ball is, let's say, 2,000 kilograms per cubic meter. So as I make, if I have identical balls with identical velocities, identical V start, then if I launch 2 balls, same material, but different size, they're going to travel differently with air resistance. And the reason is because the gravitational force depends on r cubed, the volume. The air resistance depends on r squared, the cross-section area. So bigger objects aren't the same as smaller objects. And so that'd be pretty cool. So how would, if you throw a whole bunch of balls of different size, what would their max range be? Number 2, is it possible for max range to be with an angle greater than 45 on flat ground? And the answer is yes. And I'm not going to tell you how, but there actually was, it was a projectile that launched very, very, very far, and the maximum range was at an angle greater than 45 degrees. And I don't want to say too much because I want you to think about it. Okay, so that's lesson, I think that was lesson 6. I'm not sure what the next lesson is. I'm kind of winging this as it goes along, but I hope you find this useful. I'm going to have a link to the rest of the series, the playlist for the series down below. There will be a link to this code down below, so you can use it if you want to. I always think it's better just to start over and type it yourself, but you do what you. So that's that.